The next section we're going to work on is going to be our in place of 4.6 completing the square. We're going to be working with radicals here. There's really three main rules we have to learn with the radicals. We're going to start off with the simplest and then kind of work these three in. When I say to simplify a radical, I'm not asking you to use a calculator. The calculator answer will not work. We never want a decimal when I ask you to simplify. So we have a couple of properties here that say for multiplication, I can multiply two numbers that are both underneath a radical. Okay, same thing with division. I can divide two numbers that are both underneath a radical, and I just do the multiplication and the division like I normally would. Like as you can see in this first example, I do not have I can't multiply this 3 times 49 because the 3 is outside of a radical and the 49 is inside. So what I have to do is simplify that first. So I would have 3 and the square root of 49 is 7. So I'd have 3 times 7. The answer to that is 21. Okay, so the next thing we're going to take a look at is what are the three rules to have a simplified radical. And the rule number one is you can have no perfect square factor under the square root. So I can have no square root factor underneath the radical symbol. What is a square root factor? And this is going to be a very important list for us to write down, or numbers that you should be familiar with. Okay, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. And this list again can keep going on. 121, 144, 169. So what am I doing? Where am I getting these numbers from? Okay. 196. Ooh, that's a bad 9. 225. Where am I getting these numbers from is twofold. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. Or if I can take the square root of these and I would get a nice number back. The square root of 4 is 2. The square root of 9 is 3. So these are the main numbers I'm going to be looking at. And of course, there's infinite amount of these. I could make this list longer and longer and longer. We normally don't need to go over 225, but sometimes we do. And hopefully as I go through a couple of these problems, you can kind of see that. But the first rule is you can have no perfect square factors underneath the square root. Okay, this right here, no perfect square. So what are factors? Factors are when you have two numbers that are multiplied together. Okay, if the number underneath the radical can be written as the product of a number and a perfect square, then it's not considered simplified. So if I go back and look at this second example here, it's the square root of negative 18. Okay, first of all, I can't multiply this negative 1 and this 18 because this is outside and this is inside. So what I have to do is look at this 18 and ask myself, can I simplify it? Okay, is there a perfect square factor of 18? And this is where students always get confused. What are the factors of 18? Okay, a student might say the square root of 3 and the square root of 6, and I would say that's absolutely positively correct, but can you simplify the square root of 3? The answer to that is no. Can you simplify the square root of 6? The answer to that is no. So I wouldn't want to write the product of 18 as 3 and 6. Well, what if I wrote it as this? The square root of 2 and the square root of 9 and the square root of 2. 9 times 2 is 18, but what's the square root of 9? The square root of 9 is equal to 3. So to simplify this, this is mathematically considered simplified because I rewrote 18 as the square root of 9 and the square root of 2. Now, if you're absolutely positively terrible with numbers, okay, what I can do to use my calculator is I can hit 18 divided by, and I can try from that list of perfect square factors any of these numbers that 18 might be divisible by. And I'm hoping you know that it's not 16. We want to try the largest number first. I hope you know it's not 16. Then we would try 9. So we would go divided by 9. Oops, let me go back there and delete that. Okay. And as you can see, 9 and 2 work. So I can use my calculator to help me, but it doesn't give me the full answer. So there's where the 9 and 2 came from. Okay, and of course the negative out in front stays there, so it'd be negative 3 square root of 2 is the simplified form of this. So let's take a look at a few of these examples. Okay, this first example would be no solution, because I'm not allowed to have a negative underneath a radical. I threw that in there just to see if you remembered those rules. Okay, z squared. What does z squared mean? It means that is z times z. There are two of them, so this would just simplify to z. Number 5 would be written as the square root of 16 over 25, which, again, back from my very first rule here, anytime I have the square root of two numbers underneath a radical, I can write those as two separate radicals underneath a fraction. So I can write this as the square root of 16 and the square root of 25, and hopefully you recognize that the square root of 16 is 4, and the square root of 25 is 5. Now, how come I can have a negative underneath this radical? And it's because I had to do the math first. Once I square negative 4, it's going to equal 16, so there's no negative underneath the radical anymore. Let's take a look at a couple problems that are going to look like this at Desmos. Okay, so again, when I have the number 75, I need to go back to my list and ask myself, is 75 divisible by any of these perfect squares? Okay, so when you're doing this, again, you might not be great with numbers. So I put in 75 divided by, maybe you don't recognize that it's not divisible by 64. If I get a decimal, it doesn't work. 75 divisible by 49. 75 divisible by 36. Where am I getting 36, 49, 64 from? Those are my perfect squares. Okay, they have to be less than the number that's given. 75 divided by 25, that works. Okay, so I'm going to rewrite 75 as the product of the square root of 25 times the square root of 3. Here's where I got the square root of 3 from, and that would equal 5 square root of 3. So this is the simplified answer to that problem. Look at number 108. Okay, so again, I can do the same thing and go 108 divided by 81. Doesn't work. 108 divided by, and again, hopefully we look at these, 64, you might think it works. It does not. 108 divided by 36. And that works, okay? So this would be written as the square root of 36 times the square root of 3, because 3 times 36 is the same exact thing as 108. And I can simplify square root of 36 to 6, square root of 3. Now, let's say that you were doing this problem and you said, oh, I think 108 is divisible by 4. Okay, and it works. So let's say you wrote 108 as the square root of 4 and the square root of 27, and you simplified 4 to 2. This would technically be wrong. Why is this a wrong answer? Because 27 can be written as the square root of 9 times the square root of 3, and 9 is a perfect square. So we'd have to do 2 times 3 times square root of 3, which would give you 6 square root of 3. That's why I highly suggest that you find the largest number first before trying those smaller perfect square numbers. So there's going to be a few problems like that. And then we're going to multiply and divide, okay? So to multiply, we simply multiply the numbers times the numbers, the square roots times the square roots, and then we simplify. I cannot multiply a number times a square root. So again, if you look at this first example, I've got square root of 3, square root of 14. They're both underneath the radical. So I can use my calculator here if I'm not great with numbers. I can hit this 14 times 3, okay? And I can put that back underneath the radical. Now notice, if I multiply two numbers that are under a radical, I put it back underneath the radical. Okay, now, is there a perfect square factor in 42? So is 42 divisible by 36? No. Is 42 divisible by 25? No. Is 42 divisible by 16? No. Is 42 divisible by 9? No. And is 42 divisible by 4? And the answer to that is no. So this is simplified right here. There's no perfect square factor. Now, some of you might be saying, well, what about the square root of 21 times the square root of 2? That definitely multiplies to 42, but you can't simplify this. So again, this is completely simplified here. Looking at the next example, this 5 and 2, I can multiply because they're two numbers. So it would be 5 times 2, which is 10. I can multiply the 3 times 6, which is 18. And now I have to try to simplify the square root of 18, which we've already done. 10, square root of 9, square root of 2. I can't multiply anything yet because they're not a number times a number. But what is the square root of 9? It's 3. You can't do anything with the square root of 2, so you leave it alone. And this would simplify to 30 square root of 2. Okay, for this problem right here, you don't do anything with a 2, but the square root of 5 times the square root of 5 is square root of 25. And I can simplify the square root of 25 to 5. And the answer to that is just 10. So again, going back to multiplying, multiply the radical times the radical, and then simplify. Multiply the numbers times the numbers. Once you simplify, if you can multiply the two numbers back, we do that. So again, this 10 and 18, I couldn't multiply because this is outside. But once I simplified 18, this square root of 9 became a 3, and I can multiply the 10 times 3. Let's take a look at division here, and same thing. We divide the numbers with the numbers and the square roots with the square roots, and then we simplify when we can. So looking at this problem right here, this 5 over negative 10, this could reduce to a negative 1 over 2. And then now I can divide 32 over 2, which gives me a square root of 16. Now I want to simplify the radical, and this happens to be a perfect square, so it would be negative 1 times 4 over 2, which is negative 4 over 2, which just simplifies to a negative 2. Okay, now this problem right here is a little bit different. I actually don't think I'm going to give you any like this. So what I want to look at is this. Let's scratch that out and just do this. Okay, so can I simplify this problem? Well, I can't divide 32 over 4, even though I know it equals 8, because this is underneath the square root. So what I want to do is see if I can simplify the square root of 32. Is 32 divisible by any perfect squares? 32 divided by 16. Yes, it is. So this could be written as the square root of 16 times the square root of 2 all over 4. Notice I don't do anything with a 4 because it's not underneath the radical. Now, what is the square root of 16? The square root of 16 is 4 square root of 2. So all I did was rewrite the top divided by 4. Now, can I divide anything? 4 divided by 4 cancels, and this simplifies to just the square root of 2. Okay, so there's going to be a couple problems like that in Desmos, or in Delta Math. This will be the first section of the homework.